Hey, hello everyone. Welcome to Hack the Mountain 3.0. We are here with our seventh session of HTM Qubits, and today we are going to talk about the topic on like TensorFlow, MLOps with TensorFlow, and we have with us Mr. Bhargav Patel. He will be talking about and taking the session on MLOps and TensorFlow. So he works in a company called Truecall and Truminds software system. Sorry for the miscall. And we welcome you, Mr. Bhargav Patel, and yeah, the session is yours.
Okay, great. So, hi everyone. Thank you very much, Head the Mounts, for having me. Uh, I hope my screen is visible on the right. Yeah, great. So, to all the participants, welcome to this session. As they introduced, my name is Bhargav Patel, and I'll be taking a session on machine learning operations using Airflow and TensorFlow Extend. So this is going to be a bit technical session. I won't say a bit. I have very heavy technical sessions, but I have done my best to make it as much as fun and interactive possible. So just get your minds ready, and it's going to be an amazing session for sure. Okay. So let's start with this. So, before starting this session, let me just tell you why and who should attend this session. So, uh, this session is for those who are beginners in the area of machine learning operations, even in the machine learning as well, because this session will give you a very good understanding of this field, a very abstract level view of how things are done in the machine learning operations, and what exactly MLOps is and what are the benefits of it. Those who are working professional, because in each and every company machine learning is used in everyday's products and their services, but using MLOps, how you can improve them, how you can improve productionizing machine learning models, you'll get the knowledge in this session. And to those who envision to build their own machine learning startup, because machine learning operations is going to be a very core value for your company. And even if from the early stage, if you can adapt to it, you will have a very rapid prototyping, which will eventually help you in gaining more customers and knowing what they actually want. Okay, so let's start with this. So but let's before moving forward, let's look at the some prerequisites. So it's not necessary to have them, if you know them, you will get the best out of this session. So some basic knowledge of machine learning, like how things are work. You don't need to know everything, but yeah, how what is machine learning, how things are going on, that would be helpful. Some fundamental knowledge of cloud computing, like AWS or any cloud computing platform, or maybe just general terminologies. And if you have an experience of putting a machine learning model into a cloud environment or into a production, you will be having the best out of this session, because you will exactly see, you will exactly know where the problem is and what is the solution, right? So talking about just a personal experience before starting, when I was doing the internship when I was an undergraduate, it took me around 2 weeks to develop a model during the internship, like Keras model, training it and all everything. But it took me a 5 month to integrate it into a production environment. So you can see the difference. Like, right, developing a model is just a small part, but putting into a production is the big part, which we are focusing today, right? So this is the outline of the session, and we'll start with a basic introduction of machine learning for those, just to set a stage, or to those who are right, definition, types of ML, and then we'll directly jump to machine learning operations. So I'll tell you what MLOps is in general, what definition is, what components are part of it. Then we'll see why MLOps, because until unless you see a problem, you cannot appreciate the solution, right? So you need to first see what are the problems in productionizing machine learning models and how we are addressing it, right? Then we'll move forward to the business value of MLOps, because see, at the end, every company wants to create a sustainable business, and to have a sustainable business, you need money. So how using MLOps you can create a business value in your company as a entrepreneur or as a employee. And then we'll move towards the TensorFlow extend and airflow. So I'll explain what this is, where this will be go, and how we can do this. And then there will be a hands-on example, right, in which we'll develop a simple pipeline using TFX and airflow. And then at that we'll have a Q&A session. And if you have any doubt, you can just meanwhile keep putting your questions over here, right? So let's start with ML. Okay, so let's try to first understanding in a very simple words. For just for our understanding, machine learning is computers learning how to do a task without being explicitly programmed to do so. So we write a code which can learn how to do a particular task rather than writing a code which can do that task, right? So this is for our understanding. But let's say if you're a student, you get exam and they ask what is ML, you need to go with this definition to get full marks. ML is the study of computer algorithm that improves automatically through experience. Same things, different words. And if you are going for an interview, you can say machine learning is a specific field of AI where a system learns to find patterns and examples in order to make prediction without being explicitly programmed. Right? All things point to a same thing, right? Now, see, this was the definition of ML, and ML is a very broad category. In ML, there are multiple segments, and if you cover them into the major areas, one is a supervised learning, in which you have a data which is labeled data. So, if you are lucky enough, you'll get a supervised learning problem because they are comparatively easy to solve. Then there is something called as unsupervised learning, in which we don't have labels. So we prepare algorithms to understand data, its characteristics, and then divide segments of it. And then there is completely not new, completely different reinforcement learning, which has a different approach to resolve it, right? So all the machine learning algorithms and everything, they are broadly categorized. They can be broadly categorized into these three domains. Now, you'll see, okay, yeah, we know this, right? Any Udemy or Coursera course or any YouTube bhaiya will say all these things. Where is machine learning operations? And when we'll start with it, right? So this was about ML. Now let's move towards what is MLOps, right? So you have basic understanding of ML and you want to know how I can productionize my model. How can I make sure that the model that I prepare can be used by thousands and millions of users? Is there a what is the way to do so, right? So what is MLOps? So whenever it comes to the operations, like machine learning operations are a set of practices. So in terms of MLOps, it's the engineering practices which aims to unify ML system development and deployment, not just productionizing, but developing a model and deploying a model, and make these practices streamlined and standardized so that things can go at a high performing level. There is no service downtime, and you can quickly run through all the components of the pipeline, right? And there are mainly three parts of it. If you divide MLOps into three broad categories, one is the model development, second thing is a deployment. So you can develop model easily, or not easily but fast, deploy them fast, and third one is monitoring, how your model is performing into a production environment and what changes are needed time to time, right? So this way you can represent MLOps in a broader terms. But why do you care, right? Because see, we are data scientists or we are machine learning engineers. We said that hey, this model works on my Jupyter notebook. Can we just push this whole Jupyter notebook into production environment? That's actually not possible, right? Or either we prepare a model and give it to operation teams or DevOps team. Hey, that it is your problem. Now you can make sure this model is available to others. But when you go in an industry, it doesn't matter small company or large company, things are not done this way. Teams has to work collaboratively, and to do that we need MLOps, right? But maybe you can say like I can put my model into a AWS EC2 and let it work over there. People will send a request and they'll get an API response. But what if your model gets old and the pattern of data change? You maybe need to retrain it. Maybe you need to monitor it. Maybe you need to check what is the quality of output that model is provided. What if there's a data drift? So, but putting it into EC2 won't satisfy these things, right? So you need something that can address all these challenges at once. Because in a survey, it has been proven that 80% of the time, model whenever a new model is prepared, it remains into a developing stage or experimenting stage or contemplating, right? And less than 20% it goes into a production where it interacts with the direct users. And see again, like 88% did not progress beyond experimental stage. And we know that those who have worked with the machine learning, they know how much time we spend in understanding a model, developing a model, fine tuning a model, and thinking about it's not going into a production. It's a bit of heartbreaking and also a loss towards the business. But there is one more observation, is that those companies who adapt to AI, they have a higher profit margin compared to other. which is a huge advantage in the industry. So MLOps helps in this segment, but why? Right? Why there is no, developing a model is not enough. Putting it into a EC2 is not enough. So we'll see. So I've divided this into a main four part. One is the data dependency. I'm looking for data that is this big. There are multiple different types of data set available. Let's say you train your model into one type of data set and you put it into production, and you are getting the live data from the customers or from any let's say streaming platform. What if that distribution of that data change and your model has never looked into that data? It will start performing not like below expectation. It may perform completely random because it doesn't know what this data is. It's never trained on it, right? And one other thing is, how will you reproduce the same results if the data change? How will you maintain a log? How will you see what exactly goes wrong and what you need to do and what you need to make to change, right? Because one thing is for sure, when you put a ML model in production and it is directly, it is getting data from the users, it is working autonomously. Incoming data will change time to time. The distribution of the data change, the values of the data will, let's say sometimes change. And if it is not equal to training data, your model will start performing differently, and it can cause a lot of issue, including harm to the business as well, right? So this is the first problem. Second one is simple to complex practical topologies. What does it mean, right? So let's say you are running a multiple loosely coupled pipelines on the cloud, and there are certain things going parallelly, and it involves human dependency and let's say component dependencies. Whenever there is a human interaction is involved, productivity gets decreased, because every humans works differently. If there are multiple humans interaction going on inside a pipeline, where every time something goes wrong, some person has to come and see, hey, what goes wrong, and he or she needs to correct it. It takes time, and whenever the time is extended, it impacts your business, it impacts your pipeline, it impacts a lot of things, right? So that's the one thing that with MLOps concept could be resolved, and we'll see in the subsequent slides how we do that. Second one is feature engineering pipeline must match training and inference, right? So you are training your data in your Jupyter notebook, and you are doing some feature engineering in your notebook, and then you are pushing the model to a production, and you write the code, everything is working fine. After some time, you realize that, hey, maybe if I add this feature, maybe I can get a better accuracy, and then you push the model again with that feature added, but you forgot to update the let's say in feature engineering in the inference model. It can cause a huge amount of problems by like your actual accuracy won't meet your training accuracy. So how you can verify that all the changes that you made in feature engineering while training a model goes directly into a production and it remains the same, right? So there are MLOps can resolve this issue, right? And if the, let's say if you increase the complexity, like ensemble learning or federated learning, things can get much more complicated because this required a very highly complex parallel pipelines. Managing those pipelines at the same time, it's very tough, and we need a solution that can address these issues uh, simply, effectively, and without any tedious job, right? So third one is heterogeneity and scale. So what heterogeneity and what scale, right? Because whenever we do a project in college or maybe an internship or somewhere, we can see that, okay, 10 users can interact with my model in a cloud. But what if I scale it to 10 users, to 100, to 1000, to 10,000, to 1 lakh, to 10 lakhs, maybe 1 crore users? How will you achieve that scalability without, involving human interaction and reducing it as much as possible, right? MLOps address this issue, but there are multiple challenges. See, as a developer or as an engineers, we know that one particular library or framework is not solution for each and every problem. We use multiple libraries and solution like TensorFlow, Cafe, PyTorch, Scikit-learn according to the needs, right? And we work on different language. Sometimes in production we are working with the Python, but let's say you are putting it to a production, you need Scala, because Python is, let's say, good for data scientists, not very good for production environment. You need Scala type of language which is easy to run into the servers. Then inference and training engines, like there is training is going on in one end, there's inference is going on one end. Both parties need different kind of outputs to continue the pipeline, right? All these issues needs to be addressed at the same time to achieve the scalability and to keep things simple as much as possible, right? Fourth one, that is collaboration and process. So for those who knows these three phases, it's a very old, let's say, comedy not cartoon comedy series kind of a thing in 1950s, where these three people stays together, they live together, but somehow they end up एक दूसरे का काम बिगाड़ना. So they don't intend to make another one suffer, but they somehow end up doing it. So if you're not using right MLOps tools, your data scientist, ML engineer, and data engineer might end up increasing each other's work, because there is not a single established process or rules or practices that is making sure that these three roles move forward into a single direction. And once you involve MLOps into your daily routine, you get this trial. We all know these phases. We all are fan of Star Trek. So collaboration and process, which these four issues are addressed by MLOps pipeline or MLOps engineering practices. Right. So, but how? Okay, we talked about issue, we talked about what can go wrong, and I said that MLOps can address these issues. But the question is how, right? So, how MLOps address these challenges? So, if we start, first thing that we can all think of is the automation. We need a solution that can automate a lot of things, from developing a model to pushing it into a production to monitoring it to serving to a users. And if something goes wrong, it should let us know, hey, this has gone wrong, this seems the issue, this could be the solution. So that is the final level of automation that we want to reach using MLOps. Continuous X. Why continuous X? So those who knows DevOps, they know something called as continuous integration, continuous development, CI/CD. But in this, two other things are added: continuous integration, continuous development, continuous training, continuous monitoring. So these four things had to be gone hand in hand and in an automatic fashion to take care of the pipeline without any kind of human intervention. This is what MLOps, good MLOps pipeline can do. Versioning. Let's say there is a team of data scientists working, and they are trying to get a good amount of accuracy, and they are trying different type of feature engineering, different type of frameworks, different type of model. How will you version them? How will you control them? How will you track them? Or let's say if something is updated and we want to push new, and if in production it doesn't go well, we want to revert it to back. That's where versioning comes. So we need a versioning tool inside our MLOps tools arsenal to control version of our data, model, and code. Experiment tracking. As I said, multiple people working on the same problem with a different approach, and they are trying different experiments. There should be a central paradigm which tracks all the experiments, which makes it easy to compare those experiments and get the best out of it. And testing. So when we say testing in terms of full stack development, it's more of a unit testing or integration testing. But when it comes to MLOps, there are a lot of other things that needs to be tested, including unit test, integration test. Then there's a data drift, model testing, infrastructure testing, monitoring continuously, testing, continuously monitoring the health of the pipeline. All these things comes under the section of testing, and that needs to be continuously done. As I said, monitoring. You need to monitor how your model is performing after you upload it to a production. You need to see how it is performing in terms of different performance metrics, its quality of service, and all. Then comes the reproducibility. The reproducibility is the least focused area in most of the time, but it is very important, because whenever something goes wrong, you need to make sure that you can reproduce that problem to solve it, to understand it, what exactly goes wrong, what was the reason why it goes wrong, something called as root cause analysis, and how we can resolve it. And last comes the ML infrastructure. In university or in early stages of career, we more focus on developing the uh, high quality model which works very good. But when it comes to production, we forget about an ML infrastructure that is needed to sustain that MLOps pipeline. And ML infrastructure is a big part of MLOps engineering challenges. So this 8 things address all the issues that we have. But still, these are just concept. How would you trace it to a tech stack? What is the tech stack that you need to get all these things done? That's where that's how we that's which we'll see in the upcoming slides, like what kind of tech stack that we can use to achieve them and how we can do that. But let's say let's assume that somehow we have been able to do all of these things. So how will it look like? So a well developed MLOps pipeline will look like this, in which there is a components to get the data like feature store and all, to analyze the initial data. Then there is a complete big pipeline over here. This is the development stage where all the development and testing happens. You analyze your own model, like how your model is performing. Then you push a source code. Then there's a source repository. Then there is a place where you package your pipeline, and then you put it to a deployment. And once that is deployed, it should work autonomously, including data extraction, validation, preparation, training, evaluation, and validation. This thing should be working autonomously without any kind of human intervention. And even whole pipeline should work without any kind of interaction needed. It should be self-sufficient pipeline that it is continuously, training a model, serving a model, monitoring it, and our job is just to monitor it. And if something goes wrong, which is which requires a human intervention, we solve it. But explaining this whole into the one session, it's a bit tough. It's taken a lot amount of time, and we don't have that amount of time as of now. So for this session, we are just focusing on this part: automated pipeline and ML metadata store. How we can achieve them, how we can build it, right? There are other tools which does this, and there are a lot of open source tools available. If you just Google it, you will find them to monitor your pipeline, to put it into production service and everything. But as of now, we are going to focus on this big chunk, how we can do this, right? But hey, this developing this pipeline seems more like a very hard work. You need a good amount of time. You get a good engineering talent to work on this. But if I let's somehow able to develop it, will it create a business value for me? Well, this actually does. If you have that pipeline, you reduce the time of development of a machine learning model, and reduce the time of putting it into a production. So the time to reach to a market is decreased. You can get instantaneous feedback from the users, and then you can keep updating it, because the more faster you iterate over your business value, your core value, the more faster you can improve your product, and you can actually give user what they want, rather than a very highly accurate model. Second thing is improving collaboration between teams across all level of technical expertise. So all the, let's say, software engineer, machine learning engineer, data scientist, DevOps engineer, data engineer, everyone can work on this pipeline. They have a different access control to this pipeline, but they can work collaboratively without hampering each other's work. Without working against each other, they can work collaboratively towards a single direction with less headache, right? Increasing reliability, performance, scalability, and security of ML system. Because once you have this system, your system will have a component of security, scalability. It will be continuously monitoring your performance, and it will be continuously reliable, as you will be monitoring the health of this entire pipeline. Streamlining operation and governance process. So this components comes when you are working with the public data. You need to have a very strict operational and governance process to get trust of the people and make sure that data is safe with you. And the second and the last one, increasing returns on investment of ML project. Why this was is important for the business? Let me tell you. If a company hires a machine learning engineer, a data scientist, or a data engineer, they pay them a good amount of money. If you are going to a good company with good skills, and let's say you work on a model for months, let's say 2 3 months, you develop a model, but your company has not been able to put it into a production. Maybe you'll say, I'm getting a salary, why I should care? But hey, company is spending on you, so they want to increase the investment, sorry, increase the returns on the money that they have invested and they have given to you. and the model that you have prepared. That is where MLOps is needed. If there is an MLOps system already ready, developing and pushing a model won't be a big task. It won't take a month. You'll just write the code, update the model, push it into production, and things should be ready over there to take your model and give it to users, right? So this was all about what concepts that we need, what are the major challenges, and how what business value which we can achieve, right? But how, you know still they are just concepts. What are the tech stack that we have already that will help us to achieve the small this automated pipeline part? So there are a lot of open source technology already available for this, and currently we are focusing on two part. One is the TensorFlow extend, which is from Google, and second one is the Airflow from Apache. Both of these tech stack are open source. You can access them just by googling about it. A lot of documentation is available. And for this session, our focus will be on how they work together, not on how to code them, but how those different components work together. Codes are already available on the web, so you can if you know Python, learning this won't be a challenge for you. But yeah, understanding how they are interacting, that is much more important, right? So let's first start with the TensorFlow extend. So it's a Google production scale machine learning platform based on TensorFlow. So if you know TensorFlow, TF extend would look very similar to you in terms of syntax and this architecture. So it will be able to grasp it fast, and it provides a framework and shared library to and certain common components for you to define, launch, and monitor your machine learning system. So developing a pipeline with TFX is very easy once you have a basic level of understanding. It provides a toolkit for building ML pipeline, right? So it has ready-made components available with it, and there are certain ready-made components that you can use, and you can design your own components as per your need as well. And it is compatible with the tech stack like Airflow, Beam, and Qflow. For those who have heard this name for the first time, Airflow, Beam, and Qflow are called orchestration platform. They take your pipeline and they show it to you graphically. They schedule it. They trigger the events that whenever there is some kind of event happened, you have put a trigger on it. Let's say if your model's accuracy decreases less than this, or quality of service decreases to this level, you need to update the model. If there is a data drift happening, you need to retrain your model on the new type of data. These things are scheduled by Airflow or Beam or Qflow. You can use as per your requirement. And it a set of standard components that you can use as a part of a pipeline or as part of your training script or production script. And it's, as I said, standard functionality for your overall pipeline. So this is the abstract level view of a TFX library. So TFX provide a data ingestion module, this one, then TensorFlow data validation. So see, whenever we are developing a pipeline, we need certain components. One which collects the data, one which pre-process the data. It makes sure that data that is we are moving forward, it is correct in the correct format. Third one, which can transform your data into the which can be given to a model. Fourth one, which can train your model and hyper tune it. Fifth one, to evaluate your model, whether the model that you have prepared, is it ready or not? Is it good enough or not? And then comes something that is called pusher or a validation outcome, which pushes your model into a production, and then model server, which serves that model as the API endpoint, right? So these are mainly 7 components of TFX library, and each components have their own functionalities and utilities. And we'll discuss about all of them step by step, how they are getting connected, and we'll see if you have time, we'll see how they're how you can put it into a development and production code, right? So this is what overall structure looks like if you are working with the TFX, regardless of it's a Airflow, Qflow, or any other thing. TFX structure looks like this. So it's the schema and how different components are dependent on each other and how they interact. So when we start working with the TFX, first we need a data. So the example gen components extract the data from the data source, and data source could be anything. It could be, let's say, Kafka, or maybe a MongoDB from which you are taking the data. It depends on the overall architecture, right? Once you have the data, The data is given to a component called as statistics gen. And now what statistics gen does is it calculates the statistics for the data set. So those who have studied college level statistics, we have something called as descriptive statistics: mean, median, mode, standard deviation, let's say range, minimum, maximum. What are the missing value in your data set? All this initially, if you are working on an ML problem, we need to do it by your own hand. If you just give it to a statistics gen component, your whole data set, it will do it for you. You'll get a very good GUI based output in that development stage, which tells everything about the data, right? And once we have this, we pass it to a something called a schema gen. Now, what schema gen does, it takes all those statistics and generates a schema as its name suggests, for sure. But that schema is very important because it contains all the information which describe what type of feature we have. We have a string feature, we have float, we have a number, we have integer, we have boolean values, and it fix let's say a set of rules which says that if we are moving with the training a model or in the production, data has to be in this schema. If data is not in this schema, it will start showing error, or the your pipeline would fail, and can modify your data or make changes in the previous component. And then comes example validator. Now, example validator is an amazing component of TFX which looks for anomalies and missing values in the data set. So when I say anomalies, they are generally outliers. And there are multiple ways to detect outliers in your data set, and eventually to do it by your own. But if you pass it to example validator, it automatically tries to find all the anomalies present in your data set. And it also look for missing values in them, right? And if there's an anomaly, it says that okay, these are the anomalies in your data set, and further we can modify it with the next component, right? So moving forward, now new component got added into a pipeline, that is transform. This is the component where all the feature engineering goes. This is the component when you spend your most of the time, not most of the time, but a good amount of time coding, like what kind of feature engine do you want to do. If your data set has an anomalies, in which way you want to replace them. You can use mean, median, mode. Maybe you can discard those value depending on the output of the statistics gen. So all these components makes it easy for you to transform it, get initial knowledge of the data set rather than spending a lot of time in understanding it. And once your transform component is done, you have done feature engineering. We move ahead with the training part. So in the training section, there are two components: trainer and tuner. So trainer trains your model, but it is not your model requires something called as hyperparameters. Now there are two things over here. There is always a confusion. It's a very famous interview question as well. That what is the difference between trainer and parameter and hyperparameters? Parameters are the values which model is learning by learning algorithm. Hyperparameter is something that you provide externally. Hyperparameters are provided by humans. So like learning rate, batch size, number of layers, let's say number of filters you want to use, learning algorithm and all. But it is not necessary that the first value that you are providing, they will be the correct one. It's an iterative approach. That is where the tuner comes in. Tuner takes the range of the value from you, and it tests all the values possible and gives you the best possible model in terms of performance metrics that you design or decide, and gives you the best model to use for your further evaluation, right? So it's a model to do hyperparameter tuning of your model. And once you have selected your best model from the tuner, it goes to evaluator. Now, evaluator is one of the most amazing component of this, because it it just does not evaluate model. It evaluates in the multiple spectrum. Those who have experience with the training a model, they will say, okay, I think this component is just model.evaluate parameter in which I pass test data set. It gives me the accuracy, but it's not just limited to that. Let's say your model has the 10 features, and in each and every feature there are multiple let's say categorical values which are repeating at a even amount of time. How your model will behave on each category of a single feature, it can give you that. So you can check how your model is behaving in the whole spectrum of your data set rather than overall. And this is very helpful when you are developing a very unbiased model, a very, you're trying to achieve a good amount of fairness in your model, a good amount of unbiased model that is working very nicely on the whole spectrum of data set, not just one class of it, right? Just to give you an example of it, let's say I have 100 images, and 98 of them are from dogs and 2 of them are from cats. Okay, so no personal issue from the for the cats. Just give you example. And you train a model and your model always says it's a dog. So if you give those 100 images to a model and you get overall accuracy, you'll see, hey, my model is 98% accurate. But if you slice your, or sorry, if you bifurcate your model into the let's say dogs and cats uh, input data, you'll see that for the dogs it's working 100% fine, but for the cats accuracy is zero. This is where you can see your model is biased towards certain type of output, right? Now comes the something called as infra validator. So till this point, we were talking about training a model, getting the right model for our production. Now it's time to push it into production. But as I said, ML infrastructure is one of the big part of MLOps. So how you make sure that your model is perfect for the infrastructure and your infrastructure is perfect for your model? Not perfect, but good fit for your model. This components plays a very important role over there. It takes your model, it's put a very small, let's say a pilot model serving on your infrastructure, and it collects the data. It collects the data in terms of how your infrastructure is performing, what is the workload going on, how much your processing units are occupied, and it gives you those results, which will eventually help you in understanding whether you need to change your infrastructure or make any kind of modifications, right? And at the end comes pusher. Now, when we train our model, the model we get is, if we are working with the TensorFlow model, we get into .pb protobuf format. But if you want to serve it into a browser with the TensorFlow JS, you need a different format of model. If you want to serve your model on a mobile applications or give it to edge processing, you need TensorFlow Lite, right? Pusher comes over here and it gives you the model format which you want, so that you can serve it without any kind of dependency on a single format. You can have multiple format out of it, right? So this was overall components that helps us in addressing those challenges into that particular small automated ML training pipeline domain, not overall whole, because you need other tech stack and components to do it, right? But let's say you got over here, we had I think around 10 to 13 components, but your company creates the custom components and they reaches to 100 plus components, and sorry, 1,000 plus components, and there are 100 plus pipelines. Just imagine managing a code for this much pipeline and components. How will you do it? Because definitely it's gonna impact your mind a lot. It will make your life hell. You'll be spending a whole night going through the codes and seeing where things go wrong, where is the log file, what exactly the issue is. That's where Airflow comes into the picture. So what exactly Airflow is, right? So Airflow is a platform which is which programmatically author, schedule, and monitor workflows. So this that this one that we prepare, this is called a workflow, in which there are specific set of instructions going on. There are specific components that are dependent on each other, and they are moving sequentially and parallelly according to their dependencies. And this workflow is managed by Airflow. It schedule them, it monitor them, it author them. It means, let's say if there is an event and you have set a logic that if this event occurs, please start the training process. So it will start training process and activate those components. And TFX uses Airflow to author workflow as a directed acyclic graph. We'll see in some time how it looks like, but those who have done computer science or any uh, field of engineering, I would say, they know what directed acyclic graphs are, right? And the Airflow scheduler execute tasks on an array of workers while following the specific dependencies. So you might be, thinking that this pipeline seems like the single worker is working on. But what if the volume of data increases, right? And you need to transform that data at the same time. You can actually increase those transform workers alone using Kubernetes and Docker to achieve scalability. And all these things could be maintained by Airflow. You don't have to do it manually. Airflow takes care of them, right? And it has a very rich interface in terms of command line CLI. You can use into production. You can monitor it, and it's very easy to use and easy to install as well, right? So this was about the component, and I'm pretty sure as of now we'll be thinking, okay, he has said a lot of gibberish things, but we are not sure about it, like how we can use it, how it will look like, and we'll get a more understanding when we see actual things happening, right? Okay. Yeah. So let's try to let's do a hands-on experiment, right? And I think we are reaching to a time limit, but let me try to squeeze it as much as I can. So PFX helps in one thing majorly is that we can combine our converting that development code into a production code is very easy. Let me tell you how. Those who have used Colab and Jupyter Notebook, they know how easy it is to debug a code in Colab. You have different small cells. You can see different values. You can debug them. You can see all the process going on. But hey, you cannot put your Colab notebook or Jupyter notebook into a production. You need a particular .py file that goes into a production that does all the things. And believe me, you don't want to make changes into a .py file into a production, because these things could happen. If those who are like, it was everywhere, Instagram, Twitter, everywhere, that suddenly Android users receive a notification from the Airbnb test day. uh, this type of scenario, this is a very this has not any negative impact on the company, but if something goes wrong into a production environment while editing a file into a production, that's a huge mistake, a very huge mistake. So you want to make sure that you change code into the development stage in the Colab notebook, but you can easily convert into a production environment, a .py file. This is where Airflow comes in. This is where TFX helps us. So considering that time, we won't be spending much time in understanding the code, but we'll try to understand how Colab converts your code into a production. So you can see that I've written this code and it has all the components that we have mentioned, starting from example gen to, let's say, statistics gen, and then schema gen, example validator, transform, trainer that trains your module. For the sake of timing, I have not added the hypertuning part. We have evaluator, and then we are pushing our model to production. But this is the notebook. You cannot push this notebook into the production. What you can do is, if you look at this transform cell, I have written this command over here. You know what this does is, when I run this cell, it creates a file, and I can see this file over here. Maybe rather than running whole code, if I try to do that, uh, yeah, you see taxi constants.py. You get a .py file from this code, and this code can work with the Colab as well. So you don't need to you just need to make changes over here, quickly test into a Colab, and then download these separate files. Let's say this two, taxi transform, and this one, and put it into a production. Now, how to put that into a production, how to squeeze it into Airflow. I have all things available on my GitHub page over here. So I think Hack the Mountain teams can share this link. Due to the lack of timing, I won't be able to going over it. But it has a notebook and it has a code over here. This is the production code. This is how production code looks like. All of these things squeeze into a production code, and once you have that, and you run this setup.shell script file, setup.sh file, it will create everything that is necessary for you. You just need to follow this step and run the file. You will get whatever all the things necessary. And once you put it into a production, things would look like this. If you can see, we can see a DAG, directed acyclic graph, which start from CSA example gen, go to statistics gen, schema gen, example transform, trainer, then we are putting it to evaluator, and we are serving a model and we are pushing it to production, right? This all these things, and this is just a very small example of what Airflow can do. Airflow can manage thousands of these components, hundreds of pipelines at the same time. And if you want to scale it up, just add the Kubernetes as a backend. You have a scalability of Kubernetes, amazing scheduler as a Airflow, and a very easy programming platform as a TensorFlow extend. Develop a machine learning model development and deployment part becomes easy, right? So this was about Airflow and TFX part. And as we as you can know, we don't have time to go through the example. Leaving it up to you guys to try this out. uh, why I'm leaving this up to you and why I'm insisting to doing it. If you are if you are participating in this hackathon and somehow you're able to use this all, not all but even a small amount of practices into your code, you will see the difference. And it could be your development of a model becomes easy, and writing your code becomes easy, hyperparameter tuning becomes easy, and installing them is not a big task. It's just a pip install Apache Airflow. It will be there with all the necessary things, right? So as we are running out of time, let's end the session over here. And if you have any questions, I'm up for the questions.
Yeah, there are few questions in the chats. So, Kishetar asks, in addition to CA and CD, are there any other consideration unique to MLOps?
Yes. So while explaining all this, I think I mentioned about continuous X. Apart from CI/CD, we have continuous training and continuous monitoring. So why continuous training, right? So let's say, just give you a simple example. Let's say you put your code into a production, it's working very fine, you are getting amazing results. After a few years, the distribution of data changes because data is coming live. You cannot control the data, like training data is a batch, it's a live data, and your model start performing worst because it has never seen that data. What continuous training does is it collects that data, it retrains the model without any kind of MLE or data scientist. It takes that model, push it into a production, and you have bam, your new model. And it can do it parallelly, it can do it sequentially. It's up to you how you're defining your pipeline. And the fourth one is continuous monitoring. So you are using, if I can, there are certain monitoring tools which helps you in monitoring your model, how it is performing, even if like it's providing a good results to our clients, how your quality of service is going on, how your infrastructure is doing. So those two things add up. Apart from CI/CD, continuous training, continuous monitoring. I think you are on mute.
Oh, yeah, sorry. Yeah, I was saying I hope this answers his question. Now we have one more question. What can be some of the deployment strategies borrowed from DevOps and can be utilized in MLOps, and how to achieve them?
Okay. So as far I know about the DevOps and their terminology, Kubernetes is one of the most important part when it comes to the DevOps. There are definitely certain other things, but talking about scalability and ease of scalability, Kubernetes is and Docker is always there. The same
Right.
thing could be done with the MLOps as well. So over here, when we are when you'll be executing that example, you'll be using Airflow as the orchestrator platform. But when you want to scale it and add the Kubernetes part, you use Airflow as a scheduler, which schedule your task, your workers, and all these workers go runs on Kubernetes to achieve the scalability. So you can use borrow this strategy from DevOps to utilize with the MLOps. And Kubernetes has an excellent support for MLOps. Even they have something called as Kubeflow, which you can use instead of Airflow, and it's there part of the package as well.
Yeah. Also, Ajay has also asked one more question. What are the best practices for MLOps?
Best practice for MLOps. Okay,
Yeah, yeah, yeah.
so the main objective of the MLOps is to reduce your headache in doing redundant work, right? So if you try to push a product machine learning model into a production, you will have a lot of issues. Issues like, let's say somehow your model stops working. You get an error, okay, model is not performing well, or you get some other kind of errors, runtime errors. uh, you need to make sure that whenever you create a MLOps pipeline, you need to address those issues. And talking about the best practices, how to do them, make sure that you are not taking data directly from the source. First thing, always have a streaming platform like Apache Kafka before your data ingestion components. That's the one thing. Second thing is, make sure all the components that you have, they are easy to replace and they are easy to monitor. So if something goes wrong, if something goes down, you should have an alternative approach to do that. So that is where loosely coupled architectures comes in, where your each and every component is a very less dependency on each other. So one failure and one point does not impact others, and your pipeline should be continuously working, maybe at a, let's say, lower efficiency, but it should be working. And if you talk about 100% MLOps best practice, you need to make sure that the downtime is nearly zero. Your pipeline is always healthy, it's working, it is taking care of all other things.
That's awesome to know. We have one more question. So, is MLOps the future?
uh, See, MLOps is a one field of engineering that will be part of the future. Yes, it will contribute. It will be there, because if you look about all big techs, Spotify, Google, Microsoft, Amazon, they started adapting MLOps and DevOps way earlier before it becomes the mainstream. So yes,
Okay.
it will be part of future, because we are moving towards a lot of machine learning is in boom. It was in boom, it is still in boom, but there are certain changes that are happening. It's now the game is, it's not about developing the most accurate model, it's about serving that model to a user and making sure that your user benefits from it. That's where MLOps come. So if you start learning about MLOps, start implementing MLOps, you will be have plenty of opportunities to work in the future. And if you look at the new startups that are building on, they are heavily focusing on MLOps, because yes, it's a big contributor in developing the future.
That's awesome. Yeah, we have one more question. So, right now in MLOps, in today's term, so MLOps might have some limitations. So, according to you, what are those limitations, and will they be improved in future?
Uh, if you talk about the limitations, see, limitations occurs when you are not using the right components. If you ask me that whether there are components to address those limits, yes. Whether those components are open source, yes, they are open source. It's about developing a pipeline, arranging the components in a way that does not let your that address those limitations. So if you if you say I need a pipeline that does everything by itself, it runs whole company by itself, that is not still happen. It will take time, but it will. I'm pretty sure it will happen. But if you want to know more about it, because what I am explaining over here, I'm assuming that there are very few people who know about MMMs who are joining this session, because most of them will be students and very less working
Right.
professionals. And when you are a student, you are enjoying machine learning, playing with the deep neural networks, coding them, seeing them, oh, you can identify this. So currently, if I start talking about limitations and issues, it will go, like it will be bouncer. But if you want to know more about what industry is doing, what tech giants are doing to address those issues, you can follow NIPS. It's an amazing conference in which I think in 2015 they published a paper about MLOps. Not the first paper, but a paper that
Mhm.
addressed a wide range of problems. You can start from that. It
Okay.
will be an amazing paper to read.
Awesome. Yep, these were the only questions we have for now. And yeah, the session was very informative, and people are saying that the presentation was very creative. So, thanks a lot for giving such a session. And do you have any last thoughts or any comments for the audience or anything?
Uh, uh, I have one thought. Like I just want to share with the
Yeah.
students or who are in the early career, and this is from the experience and from my own understanding that I'm sharing. Many times, what I heard from the early students and people are that hey, what is going to be the future? Like, in which field I should go to get a best job or to create a business. And everyone says, computer science is going to be a boom. and let's say chemical engineering, blah blah blah. Okay, okay. Let me tell you one thing. It's never about the field; it's about the skills. Even if you are a .NET developer, but you are top-notch .NET developer, you will have amazing opportunities to work with for sure. And even if you're a machine learning engineer, even let's say MLOps engineer, but you don't know your own field, no one will be there to hire you. So it's not about going into the most field which is going which is in the hype. It's about being skillful. Even let's say you select a very narrow field and you try to excel in them, you will have plenty of opportunity to work with for sure. And keep updating yourself, keep updating with the don't limit yourself by saying, hey, I'm a machine learning guy, I will just do machine learning, because that is what I used to do. I still remember when I started my first job, I said, hey, I'm a machine learning person. I just want to work with ML. I don't care about Node.js. But in first 6 months, I realized everything is important. It's not about ML. You should know Node.js. I'm not saying be expert in it, but at least you should have a knowledge of it and an open mindset to learn it whenever needed.
Right. Thank you for such an insights. I hope like this will help all the early adapters of new technology and give them a path to kind of like start their career and all. So yeah,
Yeah.
thank you so much for joining at our 7th session of HTM Qubits, and everyone loved your session. We can see already in the comments people are saying it was a great session and very informative. So yeah,
Thank
thank
you.
you so
Thank you
much.
very much. Thank you.
Thank you. And for all the audience here, there is a link flashing down there, and you can go to our website, register now for the hackathon. Hackathon will be conducting in 17th and 18th of September. You can register your team in the link given below. Also, you can join our Discord, and you can. It's very a beginner friendly Discord server, so you can just go there, ask any question, and I'm pretty sure someone will answer your question, and your question would be solved. So that's all for today's session. Thank you for joining, and keep coding. Bye bye.